Oh, hello there. I didn't see you come in. We are Group G2ME, and this is our portable flow bench. I am Nicholas Brostow, the project lead.
I'm Hluchy, and I am the lead programmer.
Hi, I'm Jared Leahy, and I'm the manufacturing lead.
I'm Demos, I'm the financial manager.
What is a flow bench? A flow bench is a testing assembly that pushes air through a testing component. Pressure is determined before and after, and various aerodynamic properties can be determined from that data. The Rutgers Formula Racing team uses these, not this specific model, to test various components in their engine. Typically these are really big, really immobile fixtures in specialist design houses. They're very heavy, very immobile, not something you can just have in place, and they're expensive to ship out for. So as such, we determined that we could build a portable, usable, serviceable flow bench for in-house use by the Formula Racing team. We could test their various components, and we would get more or less immediate feedback on the usability and feasibility of our project. Where are we right now with the project? Well, every part that wasn't machined got put together in our New Brunswick apartment into this current assembly. What we are missing is the machinable parts from Professor Basili. Due to current circumstances, we can't get them, and so we're more or less at a standstill here. We can't do functional testing, and pretty much are stuck with the current assembly. It's about 90% assembled, and if we could get those parts, we would be well on our way to actually functionally testing this as a flow bench.
Our flow bench will be deemed successful if the discharge coefficient reading is within 5% accuracy of a known orifice value. In addition, it will be deemed successful if the fan has a 350 CFM push and pull. Our flow bench was designed with accuracy, portability, cost, and ease of use in mind. Transducers with 0.5% accuracy were chosen. A utility cart was chosen for size and portability. An Arduino will display the two pressure readings and the discharge coefficient in real time. Pipe flanges were used to allow interchangeability between orifice plates. This flow bench was designed with existing parts in mind.
For our design, we chose designs and components such that many manufacturing processes only require simple hand tools and construction. However, there are two components which require advanced manufacturing beyond simple hand tools. One of these is the orifice plates, and the other is the top plate onto which the test piece is bolted. For the orifice plates, we selected 6061 aluminum because of its easy machinability and low cost. The precision ground load carbon steel chosen for the test piece adapter was chosen because of its sealing surface requiring hardness and smoothness. By getting a ground test piece adapter, we already have something that is smooth and we know will bolt up easily to our test piece. Manufacture assembly of the tubing was, as I mentioned previously, taken place using mostly hand tools such as drills and saws. The tubes are sealed together using PVC cement. PVC tubing and flanges with silicone rubber gasket hold the orifice plates together, and there's a silicone rubber coupler that connects the fan to the rest of the tubing that provides vibration damping as well as flexibility in the system. Currently, the assembly of the cart as well as the main tubing has been completed as seen in the pictures to the right. The machining and support for the pipe assembly has yet to be completed. However, majority of the project is complete.
The future plans for our project are as follows. The remainder of the project will be held at the house in New Brunswick. The following parts must still be machined: the orifice plate and the mounting plate. Subsequent mounting holes must be drilled into the cart in order to secure the mounting plate and the flanges for the rest of the flow bench. We could see this at the red arrows shown in the bottom right. For the pressure transducers, the wires also need to be longer to connect the tap to the Arduino. The connectors for the Arduino also need to be soldered. For the Arduino code, we want a live readout. We also want to have compiled.csv data for analyzation. We are also going to try to simulate the actual running of the flow bench with CFD